In the last video, we talked about circles and recapped on our knowledge of circles. We're going to talk now about parabolas. You've come across these before at school. Those of you who haven't done further maths before will certainly have seen the graph y equals x squared, or transformations of the graph y equals x squared, which looks like this. Now, what are parabolas? We know that parabolas are U-shaped. It's one of their basic properties. In the case of y equals x squared, the parabola is an upward-facing parabola with vertex at 0, 0. But as you know, parabolas don't necessarily have to face upwards. They can face upwards, but they can also be inverted. They can be rightward facing. They can be leftward facing. These are all U-shapes, and they're all parabolas, but they're not oriented in the same way as you might be used to seeing them. Okay, so there are different orientations that a parabola can adopt. You've also recently been introduced to the standard parabola, y squared equals 4ax. We're going to look at that now. This parabola refers to a different oriented parabola to this. The parabola y squared equals 4ax looks like this. It's a right-oriented parabola with vertex at 0, 0. This equation is telling us that any point on this parabola, the y-coordinate of that point squared is equal to the number 4 multiplied by a constant a, which we'll come to in a few minutes, multiplied by the x-coordinate of that point. Okay, so that's how the equation works. What do we normally look for now in a parabola? When looking at a parabola problem, what features do we concern ourselves with? I normally look for these 5. You may have your own approach, and that's more than fine. This is just there in case you need guidance. The first feature I look for is the vertex. The vertex, as we know, is the tip of the parabola. In the case y equals x squared, the vertex is here. It's the tip of the parabola at 0, 0. In the same way, the standard parabola has a vertex at 0, 0 as well, because this is the tip of the parabola. The second feature I look for is the axis. The axis is a line, straight line, through the vertex of a parabola that splits it into 2 symmetrical parts. In the case of y equals x squared that you've seen at school, the axis is the vertical y-axis, the line x equals 0, because it goes through the vertex and it splits the parabola into 2 symmetrical parts. In the same way, for the standard parabola, the axis is the x-axis. It's the x-axis, the line y equals 0, because it goes through the vertex of the circle, the parabola, at 0, 0, and splits it into 2 symmetrical bits. What's the third feature I look for? The third feature is the focus. The focus is a point in the interior of the parabola, i.e. within the U-shape of the parabola, that lies on the axis. Just label that here. The focus is a fixed point on the axis that is a fixed distance from the vertex. The distance between the vertex and the focus, this distance here, is a. This constant that I was talking about in the standard equation refers to the distance between the vertex and the focus. What's the fourth feature I look for? It's the directrix. What is the directrix now? The directrix is a line, and I think of it as always being perpendicular to the axis, but being in the exterior of the parabola. So, rough drawing here. Let's say this is our directrix. The directrix is always in the exterior of the parabola, i.e. outside of the U-shape, and it's a fixed line that's a fixed distance from the vertex. This distance here is also a. So the a constant in the standard equation refers to 2 distances, the distance between the vertex and the focus, and the distance between the vertex and the directrix. I think that's a basic coverage of the essential features of the parabola. The fifth feature is eccentricity, which will become a bit clearer when we do ellipses and hyperbolas. But for the time being, remember that eccentricity in the case of a parabola is 1. In the next video, we're going to talk about the non-standard parabola and probably do a few problems. Thanks for listening.